Hello, teacher and class, and welcome to our presentation. And our topic is forecast the number of product sale. My group include three members: Minh Tú, Thủy Tiên, and Minh Anh. It's our table of content. Introduction. The next is the ML and DL deep learning model that we use in our project. Number three is the research method. Number four is interactive dashboard. Number five is the evaluation and improvement. And the last is the reference. So the reason why we choose this topic, we all know that sales forecasting is a fundamental aspect of business planning and decision making. Apply the machine learning and deep learning model for sales forecasting is feasible and widely adopted by business. What is the forecasting the number of product sale using algorithm and model based on the historical data to predict the quantity of products and that will be sold in the future. And the goal is have the business plan, production, procurement, inventory management, and shape their business strategy effectively. Talk about its application in the supply chain. So importing and exporting goods too much or too little leads seller to many problems such as out of stock and or overstock. So the solution here is using machine learning to forecast the number of each product which need to be imported or stop it. Will have the seller optimize inventory management. With the large-scale business, predictive tools to achieve the convenience and cost saving by using fewer professional analysis, they bring high effectiveness in shaping future business strategy. So now we will come to the machine learning and deep learning model that we use in our project. Manan will present about the K-neighbor model.
Okay. Firstly, what is a key neighbor? Key neighbor equals of the seamless supervised learning algorithm. In machine learning, when training this algorithm does not learn anything from the training data, on calculation are performed when it needs to predict the outcome of new data. KNN is also known as an instant-based or memory space. KNN for classification, data representation is of a observation is represented by a vector in an dimensional. Its dimensions represent an attribute feature variate learning phase simply sell on the training data D with their label. Reason for a new instance set for each instance is indeed compute the distance between each index determines a set of the nearest neighbor object using majority of the label in to predict the label for set. KNN for regressions, data representations in learning space similar to KNN for classification, predicts for new instance set for each instance, compute the distance between it and Z, determine a set of the nearest neighbor of Z, predict the label for Z. Okay, next KNN limitation and advantage. Firstly, advantage. Low cost for the training phase, very flexible in choosing the distinct measure. KNN is able to reduce some best effects from noise when KNN can reach the best performance among on regression methods and next limitations. have to find a suitable distance similar measure for the problem prediction requires intensive computation. Next, random forest Thủy Tiên will presentation.
Okay, now I will represent about the random forest. Random forest is a method for both classification and regression. Random forest prediction is based on the combination of many decision trees, and each tree in the random forest is simple but it's random. It depends on the choice of the attribute and training data. Uh, it has three basic ingredients in random forest: the randomization and non-Brownian combination, packaging with the so it's now either random forest algorithm. The input is a training data these learning grow tree K tree as follow generate training set D1 by sampling with replacement from the next step is learn the I tree from D1. At its nodes, it will select the randomly a subset S of attribute and split the nodes into subtree according to S. Uh, After that, it will grow this tree up to its likeliest size without running. So the final step is the prediction, taking the average of on prediction from the individual trees. The next is the Arima, Serimas, and LSTM will present by Minh Tú.
I will present about the Arima and Sorimas model. Arima models aim to describe the correlations in the time series. Time series analysis is an excellent tool for predicting future events such as changing market values. And Arima and Sarima are excellent tools for time series analysis. So what is ARIMA? ARIMA short for Auto-Regressive Integrated Moving Average is a class of model that explain a given time series based on its own past values, its own lags, and the lagged forecast errors. So we can forecast future values. Any non-seasonal time series can be modeled with ARIMA model. An ARIMA model is characterized by three terms P, Q, D, where P is the order of the AR term, Q is the order of the MA term, and D is the number of different things to make the time series stationary. And the first step to build the ARIMA model is to make the data stationary. AR model, it is an auto-regressive model is when a value from a time series is regressed on previous values from the same time series. In other words, the mathematical idea is as this follows. Next is the MA models. MA models is moving average, can be described as a weighted sum of today and yesterday's noise. In other words, the mathematical idea is as follows. And this is our data I have visualized it, and in the weekly, you can see that the seasonal is so that is very dense, but and beside the data visualized by 2 months, by monthly is very sparse, and both are seasonally stable. And you can see this is the monthly, and in the seasonal, it have the data visualized by month is regular and seasonal. So the series we choose is monthly seasonal, and this is a Sarimas. What is Sarimas? Sarimas, if the time series has seasonality, then we have to use Sarimas model, which uses seasonal differencing. Seasonal differencing is similar to regular differencing aspect. For the regular differencing, we have to subtract consecutive term, whereas for seasonal differencing, we subtract the value from the previous season. And this is the model is presented as Sarimas. And how to find the order for Sarimas or Arima, and we just run the library of the Sarimas in or Arima, and we find the function to obtain the recommended orders. And this is our result. Next is LSTM. This is a deep learning model. Long short-term memories is a kind of the RNN. In RNN, output from the last step is fed as input in the current step, and it tackles the problem of long-term dependency of RNN, in which the RNN cannot predict the word stored in the long-term memory, but can give more accurate predictions from the recent information. And LSTM has a chain structure that contains 4 neural networks and different memory block core cells. And we have the 3 definition. First is the forget gate. Forget gate is explore the detail to be removed from the block. A sigmoid function decides it, and you can see in the picture here. Input gate. Input gate, it detects which value from the input should be used to modify the memory. The sigmoid function decides which values to pass 0 or 1, and the time function gives ways to pass value, deciding the importance between -1 and 1. And the last one is the output gate. The blocks input and memory are used to decide output. The sigmoid function decides which values to pass 0 or 1, and the time function decides which values to pass 1 using 0, 1, and the time function gives weight to pass values, deciding how important they are in the equation, range from -1 to 1, and multiply with the output as sigmoid. And this in the slide is the picture with clearly the definition of the LSTM and what is the advantages and disadvantages. About the advantages, we have a memory cell that is capable of long-term information storage. Long-term dependencies can be captured. In traditional RNNs, there is a problem of vanishing and exploding gradients. Using a gating mechanism that selectively recalls or forgets information, LSTM networks deal with a problem of vanishing and exploding gradients. LSTM enables that the model to capture and remember the important context. And about the disadvantages can limit their scalability for large-scale datasets or constrained environments. Training LSTM network can be more time-consuming compared to simpler. Training LSTMs often requires more data and longer training times to achieve high performance, and it's hard to parallelize the work of processing the sentences. And about our research methods. This is a process. I will introduce about the process. First, a data collection. Gather historical sales data, including information such as time, product attributes, pricing, promotion, and other relevant factors that might influence sales. After that is data preprocessing, is clean the data by handling missing values, outliers, and inconsistencies, transform the data into a suitable format for analysis, ensuring it is ready for input to machine learning or deep learning model. Third is feature engineering, extract relevant features from the data that capture the factors influencing sales. These features may include time-based variable, product attributes, pricing information, marketing activity, external factors like seasonality or economic indicators, and any other variable identified as relevant. After that is the model selection, is choose an appropriate machine learning or deep learning model for sales forecasting. Common models include linear regression, decision trees, random forest, or gradient boosting, RNNs, or LSTM network. The choice depends on the complexity of the data and the relationship expected to exist. The important thing in model training after split the data into training and validation sets, train the selected model using that training data, adjusting model parameter to minimize the difference between predicted and actual sales. Model evaluation is assess the trained model performance on the validation set using appropriate metrics such as MAE, MSE, or RMSE. Evaluate how well the model capture pattern and generalize to unseen data. And finally, we have a prediction and monitoring applied to the trained model to forecast future product sales based on the new data. Continuously monitor actual sales data and compare it with the predicted values. Update and refine the model as needed to adapt to changing market conditions. About the data preparation, we collect file CSV, but we use just 2 files. We collect in the Walmart sales in Chicago, which is M5 competition, and I filed 2 papers using this data, so it's very reliability. And the data tag consists of 5 CSV files, but we only use 2 files. There are calendar with 1,1969 rows and 18 features, and the sales trend evaluation with 30,090 row 490 row and 1,947 features. First, we read the data, and we want to predict the number of each product sales just by on the date. This is a time series data, and we just chose date. W day, month, year, D is holiday, is weekend to consider. There's so much the ID, so we just choose the first this product ID to consider. Data cleaning, we have to see this check the noon and change the data. This is some holiday in the year, and we have if this day is the holiday, we will return it is 1, else is return 0, and this is a weekend, Saturday or Sunday, return 1, else return 0. About the data pre-processing, after we identifying and removing attributes from a training data set. And finally, we have the data integration. We have to merge two table, removing redundant attributes and detection and resolution of data value conflicts. And after repair, finally, we have this data. About the data visualization, Minh Anh will present.
Okay. Firstly, we visualize 3 categories: food, hobby, and household. By that, we can see that the number of sales of the hobby and household is similar. Besides, the number of food sales is a lost growth and stability. So we choose food to train model. Why we choose only one item? Because we use only one data frame for each model. Too easy to compare them. If we choose all 3 categories, we would train the model 3 times. And when customers use our request, they will upload their historical data set of only one product, any product, not just food. Let's analyze the monthly sale of foods from January 2011 to May 2016. It started on November 29, 2011, then gradually increased and stabilized. Next, we'll be showing the trend for food. It includes every week, month, and year. Firstly, every sale of week, we can see that the average sale is high in the beginning of the week, decrease in the middle of the week, then continue to increase again at the end of the week. We can make that at the beginning of week, before special officers will buy food and store it in the list for the whole week, so it's high. Secondly, average sales every month is high in the middle of the year, maybe because it's the peak time of the holiday. And finally, every sale every year. Initially, the number of sales were almost zero. Maybe it's time to start. In the following year, it are gradually increasing and stabilizing. The period 2015 to 2016 is really rapidly, maybe because a certain political event, so people stock up on food. Next, this is the heat map. Now we are going to analyze something. How to view the heat map is as follows. Imagine on a value axis red y flow correspond to positive 101. What is the nature? That is a value closest to the mean. Cool color suggest will focus a lot of people interacting, and red color is lower than average. We select one cell for analysis. For every week, beginning of the week has blue color correspond to high purchasing, and radially turn red means that the number of sales is decreasing. At the end of the month, there are more blue sales. Maybe it's the time to get salary, so the purchasing is high. Next, the training models. Minh Tú will presentation.
Okay, the training model we have, there are 4 model we train. First is the basic machine learning model. We train the K-neighbor and random forest. Secondly, the time series model, ARIMA and SORIMAS, and finally is the deep learning model is LSTM. And this is the result we have trained the model. The K-neighbor, random forest, and the ARIMA, SORIMAS. And finally, LSTM identified if the accuracy of the LSTM is the best model for this data. And about the dashboard, we have a dashboard for the business to use, and I will demo for it. This is the dashboard. We have the actual data chart and about the product quantity prediction. And the business can upload the file CSV, and our application will show we visualize the chart for it, and we have predict for this and the number of product predicted for the next day, and will predict the products for business for the next day using LSTM model. And I will evaluate and improve for the model, and we use the MAE. MAE is we to measure the average magnitude of error in the set of prediction without considering the direction. Is it the test sample mean of the absolute difference between the prediction and the actual observation, where all individual differences in weighted equally. MAE can be expressed as the sum of two components, disagreement on quantity and disagreement on allocation. And we use another is RMSE, or root mean square deviations. What RMS is the square root of the mean of square errors. RMS is the standard deviation of the residuals. RMS is always non-negative and a value of 0, which is almost never achieved in practice, will indicate a perfect fit to the data. With this project, we compare the evaluation index MAE and RMSEs. The model forecast result with the MAE evaluation index are as follows. And you can see the LSTM have the MAE 26, about 26, and the LSTM model result in the MAE lowest of the three models. This represents an average difference between the prediction and the actual value of the about 26. This MAE value shows that the LSTM model has a more accurate prediction ability than the other two models. So I use the LSTM for the dashboard. And we have to discuss the factor that influence the model and the contact eCommerce. Thủy Tiên.
Okay, last but not least, we will discuss the factor that influence the model and contact it in e-commerce. The first one is the historical sales data. After doing this project, I realized that the data is very important, and we want to analyze the forecast. So we need to analyze the best sales data over time. The time series analysis will provide insight into sales trend, seasonality, and pattern. And this information will help in understand the demand pattern and forecasting the future sale accurately, and it enable e-commerce business to plan their marketing campaign and inventory management effectively. Next is the day of the quick or and the week and the quicken. weekend. The day of the week can have an impact on product sale. Certain product may experience higher demand on specific day, such as weekday or weekend. Understanding the pattern allow e-commerce business to optimize their marketing effort by targeting promotion or discount on day when sales tend to be higher. The regular days and holidays sale can also be influenced by regular day versus holiday. During holiday or festive season, customer purchasing behavior may change, leading to increase or decrease sale. And analyze the impact of holiday and blending marketing campaign accordingly can help e-commerce business capitalize on seasonal opportunity. The effective of marketing campaign can significantly influence product sale. And the last is the customer behavior. Understanding the customer behavior, such as browse pattern, purchase history, or demographic information, can provide valuable insights by leveraging this data. E-commerce business can personalize marketing strategy, offer targeted recommendation, and enhance the overall customer experience to drive sales. Now we will talk about the strength and weakness need to improvement. About the strength, that we have a reliable data. The availability of reliable data is a significant strength, and this trustworthy data, when applied in an e-commerce context, it will enhance the accuracy and effectiveness of the machine learning and deep learning model used for sales prediction. About the weakness, that is our limited capabilities. And the last is the data volume and filtering challenge. About the improvement area, we need to enhance our skill in handling large data sets, implementing advanced machine learning algorithm, and improving our understanding of e-commerce domain. This can be achieved through additional training, workshop, or collaboration with experienced professionals. We need to optimize the data processing by even the challenge associated with data volume and filtering, and it's important to focus on the optimizing data process techniques. This can involve efficient data processing, dimensionality reduction methods, and utilizing distributed computing framework to handle large scale data sets effectively. And by improvement data processing efficiency, the relative accuracy of the model can be enhanced. And the last is the development strategy we want to do. The first is refine the model to improve accuracy. The next is we will develop a user-friendly dashboard for business. And the last is to explore additional application of the data set, such as revenue forecasting and supply chain management for multi-store or retail operation. And that's on our presentation about our topic, forecast the number of sales. Thank you for your listening.
Ui, xong rồi.